All right, let's get started. Thanks for watching this presentation of my code demonstration and also project demonstration. So here, as you can see, this is the interface from GreenFood. If you have the GreenFood software as a utility being installed on the machine and open that, import my final project and open that, initialize it. This should be the first page you see. If not, please remember right click on the login and click on this new login. So that will generate the initial page. Here, uh, from GreenFood perspective, it has to click this run button to really start the instances, the thread. So for my project, the first page is login. It needs to provide a username and password. For now, I only loaded myself as user. And well, the password is simply 123. I have to apologize that I haven't implemented the code hidden, well, the password hidden from implementation perspective. Actually, the coding and the implementation is still in progress, so a lot of things are not perfect. I think I still have 2 weeks working on the entire thing. So hopefully, before the really end of due date, I can finalize all those things, make things better. Well, anyway, here, since I provide the username and password, when I click this login button, it will direct me to the second page, which is module selection. As I presented before, my project is to simulate the entire process and the phenomena, the behavior of gas diffusion, and which divided into 3 major modules. The first one is gas kinetic movement, and the second one is classic diffusion. The third one is classic effusion. Well, again, I apologize that I'm a awful UI maker. So you see these 3 things looks like label, but actually it's still button clickable. So once I click one of them, like gas kinetic move, it would drive me to actually, which I named here as module one, uh, which is presenting the gas kinetic move. So starting from clicking this start button, it will asking you to provide some initial parameter like temperature. I give 100 here, and the pressure is 1 Pascal. And then using this drop-down list to select the gas that we want to load. And then again, click this button so that some gas particles are loaded and it's moving following the Brownian move principle. So if we like, we could add more gas particles with water vapor, so things like that. It's well following the ideal gas law and doing things, and you can see this process. So if you click this display current result button, it will show uh, the velocity of average velocity of each type of gas and the total kinetic energy for this entire environment. So it's being calculated behind of the screen. Well, and then if we click reset, it will bring you back to uh, the very first page. But let's just skip that and goes to the module 2, which is gas diffusion, also known as passing through the semi-permeable film, which is here. The green line is representing a film. So similarly, providing temperature, pressure. The higher temperature will cause the faster movement. I should give another value, but it's okay. Uh, let's try to loading some water vapor gas. So it's moving and well, as you can see, it's keep counting the concentration difference for this particle at two sides of container. Initially, all the water vapor are loaded in the left section, and then it moved through the firm very fast. And then once it's averagely separated, equally separated, then there's no concentration difference. Then the gas particle becomes hard to pass through the firm. It will be drag and slow down when it pass through. Well, it's the second module. So let's stop the live session demonstration here and focus on the code. So in the Greenfoot, it's a game design engine, and it's basically divided into two major objects by default, word and actor. The word is the environment, the entire UI you can see here. So the pages, you can see the login page, module selection page, and each module. And the black box here is the container, which has a boundaries that the gas particle would not able to, or not allowed to escape from this boundary. So setting about the overall environment is Word. And also in the Word, we can load actor. So the actors are acting or control the object, the action of objects. Well, each objects like button or gas particles are extend to the actor. So let's take a look into the code. The gas particle extends actor, so it would have well constructor function to describe the behavior, like the gas particle would when it colle when it has collision between a wall or when it has collision between each other, it will have different behavior. If they sort of stick together during the move, I would need them to, well, separate them, uh, set temperature, because temperature would majorly affect the the gas kinetic move, which is the Brownian move, the default movement. Calculate velocity, regular move, or path through the firm, those general behavior over there. And for the real type of implementation, also it has its own property. It's a constructor, and also the act is telling the actor to acting, the controlling the acting of actor. So during the process initialized, during this uh, process, so the act function is continuously called so that every milliseconds the act will be performed once. It would do so, which means the Basney particle would do wall collision, bar collision check, and condition check if it's passing through the form or it's escaping from a regular move or other things. So also is each object is controlled separately. So even though I'm loading 10 Basnes, each of them has its own velocity and temperature and some rest of conditions. So by acting, by using this acting, extends the default behavior of actor, described actor. The things are moved, the things are worked. Well, so the login page would contain the login button, and the login button is controlled by the login button controller. So it's firstly we need to set the appearance and then decide what is the logging process, and then do the logic right here if else, if matching or not, and then do things. If it doesn't, uh, we should say incorrect user password. Logic is like that. So as you can see here, the login button is also a actor. So the act function, uh, the class, will keep listening any performance or behavior on the screen. So when we call greenfield functionality, check if mouse clicked on this object, which is that button. If that's clicked, then doing things. So like I said, this act is being triggered every minute, uh, every millisecond. So if it's triggered, uh, well, keep listening. If it's triggered, then do the logic as described in the class. Uh, Other typically thing is like firm, well, loading the firm appearance, uh, treat it as an actor. So once a actor like oxygen particle interacting with another actor, which is the firm, then it behaves a certain thing. So those type of functions can be defined. And also wall, like the module 3, if there is a wall set in the world, the container word world, is not allowing the particles to pass through. So starting from some initial conditions, I've give temperature 50 this time, the pressure 2. Well, at this module, the initial pressure is less important because we are really defining the pressure by setting the data within this input box. So the P2 is 1, the P1 is 1, P2 let's give 20, so something like that. And then again, loading our gas particle. Well, in this module, every particle would be initially loaded uh, at this area. Well, this is not working. Load oxygen, still they're all there. Once they meet the wall, they should be bounced back. Well, this part haven't been finished yet. I'm still working on that. So basically, each module, uh, well, each word is going to contain actor. Actor is acting. Uh, Actor is triggering by the act function and acting as the function defined within the class. So we have a bunch of different type of actors, like general, it is button, and separately has its own function. Generally, it's gas particle, and separately has different properties or slightly different behavior controlled by each extension or abstract class. Display instructions, set the input box, set wall, set form, set drop-down list, set data display. All those things are controlled in actor, and individual functions are addressed within the actor subclass. All right, that's everything from today. Thanks for listening. Uh, Bye.